Really kind of excited to go through this. Just kind of a few things on the agenda here. I'm going to keep this as kind of a intro to Airflow type thing, so it's going to be pretty basic type stuff for somebody looking to get started. I'm also going to try to keep it as like vendor neutral as possible. Astronomer's kind of Airflow's our thing as a company. And we have a lot of tooling and services built around Airflow, but everything I'm going to show is going to be like open source tools that you can use regardless if you're using, if you're a paying customer or not. So that's kind of the only kind of vendor piece I'm going to get into. And then lastly, special shout out to Flavian. He's one of our customers and he's kind of agreed to join to be a part of the Q&A at the end. I'm going to show some really simple Airflow use cases, but Flavian's been a customer for a little bit and I think they have some more scaled out Airflow use. So, special thanks for him for making some time and popping on. Alrighty, so I think, if we want to just kind of dive in and get started, before I go forward, as far as questions go, feel free to jump in and ask a question at any point. Don't hesitate to interrupt me or anything. I'm trying to think if there's anything else. Anything I'm forgetting? I don't think so. We also have some people from Astronomer who joined. Ian and Pete both work with me. So thanks for them for coming and giving some moral support here. But also, I've had audio issues kind of all week perpetually. Can everyone hear me okay? And is video coming through okay and everything? Perfect. Alrighty. So then I think without further ado, I will share my screen. Dive right in. Cool. So, the first thing I kind of said was I'm going to try to keep this as vendor neutral as possible. But one thing I did want to talk about is just our Astronomer CLI tool. It's one of my favorite parts of our platform, and it's basically just a wrapper around Docker Compose that lets you run Airflow easily on your local machine. So, there's some things in here that integrate with Astronomer tooling, but even if you're not using anything Astronomer related, you can use our CLI just for a cleaner Airflow experience, especially if you don't want to get into the weeds of writing your own Docker Compose files and things. So I'm going to pull up a terminal, and let me just make sure I don't have anything running. Clear this out, and I'm going to go into one of my sample repositories. Nope. Awesome. So I have my little directory of things here. This is Astronomer way we scaffold out our Airflow images. And I also have the Astronomer CLI running here. So to get started, I'm going to do astro dev start. And what this will do is this will just take this directory, bundle it up into a Docker image, and just run a few images on my machine. So I have a local instance of Airflow running, all without needing to touch anything Docker related, but I still got all the benefits of containerization for my local environment. So let me open this up in a code editor, make this a little smaller, and pop over to localhost. Awesome. So now I have Airflow running at localhost, and quick show. I don't know how to do show of hands on Zoom, but assuming you haven't used Airflow before, I know some people probably have used it in their own organizations or have played it in some regard, but I'm going to give a quick walkthrough of this as if this is your first time seeing this interface. So Airflow has a built-in UI that comes as part of the core package, and it treats workflows as something called DAGs, or directed acyclic graphs. I have a little doc here that I can send out afterward that'll kind of walk through exactly why DAGs are a really good fit for data-centric workflows. Popping back here. So, one of Airflow's best things is that fact that it's a dependency-driven workflow tool. So you can really define dependencies for your workflows in code, and that kind of is a very nice visual representation of what your data workflows look like. So this is a simple workflow I'm going to start with, and we're going to go from this into doing some more complex things through the rest of this talk. Real quick pause for questions before, just to make sure I'm not leaving anyone behind. Any questions from anyone so far? Awesome. So, all right, let's jump into the code. With Airflow, you can see the code in this code view. You can't edit it from there. So I'm going to look into my IDE to see the code using VS Code here. So let's run through what this workflow looks like. So at the top here, I have some imports. So I'm importing the DAG model from Airflow. I'm importing something called a couple of operators, and I'm importing something called a hook. We'll talk about hooks first because they really play into what. I have my Python function here, and all it's going to be doing is uploading some files to S3. Notice the first thing I'm doing is instantiating my S3 hook. A hook in Airflow is a way to interact with external systems. So one of the best parts about Airflow is the fact that it has a really, really vibrant community around it. And a lot of this vibrant community writes connectors to external systems, one of which being S3, probably one of the most popular ones. In terms of design, hooks are really designed just to help you instantiate your connection. You don't really contain logic inside of hooks. So I have here S3 hook equals S3 hook, and I'm giving it connection ID. And this connection ID is being pulled from Airflow. So earlier, I went into Airflow, admin connections, and added my S3 connection here. So now I have these S3 connection housed in an encrypted format here. And it's being pulled here without really exposing any text into any credentials into plain text. This is kind of something we see all the time where sometimes people, when they get started, they'll just not use this hook interface, and it just makes their code a little less clean. So I have a pretty basic function here that's just going to be creating a file and writing that to disk and uploading it to S3. Just notice for the upload command, I'm using this hook interface because it already has a load file method. Getting into the DAG itself a little bit. So right now, all we've done is defined a function using hooks to grab the connections and a hook interface to actually do the logic. Getting into the DAG a little bit, there's a few parameters each DAG needs. The first of which being just the set of default arguments that are called. And this gives you some high-level information on how you want your DAG to behave. In this case, I'm defaulting to a bunch of the defaults except for the email and failure. So I don't want this to shoot me an email when it fails. I don't want this to email me when it retries. I want it to retry once when it fails. And then as far as retry delay goes, wait 5 minutes before trying again. These types of abstractions are really great because a lot of times, you're using APIs or other such things that you could run into rate limiting issues, or maybe you have too many people using a certain service. Being able to define retries and kind of failure logic right off the bat really gives you a lot of flexibility within your workflow. So next part, I'm going to define my DAG itself. So I have my DAG that I'm naming S3 upload. I'm telling it that it's going to start on 2019, January 1st. I can run up to one instance of this DAG at a time, and I'm giving it a schedule interval, meaning that how often do I want this DAG to run? I think this particular interval was left over from a different demo that I had done, and I think this translates to in cron tab like every second Friday of the month. I don't remember why I picked this, but you can get pretty complex with your intervals you have here. And lastly, I have this catch-up one, and we'll get into that in a little bit. Then as far as my DAG goes, I'm going to start with a dummy operator. And this dummy operator is just kind of best practice to start a DAG. It kind of kicks off the first piece of it. If I show you what that looks like in GraphView, I have this start dummy. And then after that, I'm creating a loop to go through I'm creating a loop to create 5 tasks, each of which call my Python function with a different name. So generate file Viraj1, and I'm going from 0 to 4 here. Lastly, I'll set my dependency here and saying that my T0 task is upstream from all of my tasks that are generating the files. And this loops through and creates a dependency tree like this. I'm going to pause here again for questions, and then we're going to go into a little bit more about the scheduling and some of the other pieces.
Yeah, I have a question, Braj. And maybe you might have said this and I missed it, but could you take a step back and explain, like, what are you trying to do here? Trying to upload data like from a CSV to S3, or what is like the overall task that you're trying to accomplish with Airflow in this demo here?
Yeah, good question. So the purposes of this, it's exactly that. I am taking this Python function where I create a CSV, and then I'm just going to load it up into S3. And I'm showing how to kind of do that dynamically with Airflow. I use a little for loop here to generate a couple of tasks, and that loops through calling my function with the right inputs, and that generates that same kind of CSV being created and dumping it to S3 5 times. If I change this 5 to, like, let's say a 15 and save my file, and now this task has 15, this DAG has 15 tasks in it, because it's going to go through and create that loop 15 times. Does that answer the question there?
Yes, thank you.
Awesome.
Do you mind going over again what the start date is for the DAG?
Yeah. So a start date is when the DAG is supposed to start. So this DAG is supposed to start in 2019, January 1st. I also have this flag here called catch-up. And what this one says is, based on the start time and versus what the current time, do you want me to backfill all of the intervals between right now and January 1st, 2019? So if this was set to true, this would create a workflow for each schedule interval. So every second Friday of the month between 2019 1/1 and today.
Okay, thank you. So the value of the start date is, it kind of introduces the capability of backfilling.
Exactly. Yep.
Awesome. Thank you.
And then you can use this parameter catch-up as well to make it so that the thing backfills. And then there's also this parameter depends on past, which makes it so the thing will backfill in order. So if the second one fails, the third one won't start. Each one will depend on the past before it goes forward.
So I think in my mind, DAG has traditionally meant more just like a mapping of dependencies. It seems like the DAG in this context is almost like it contains that job. Is that safe to say, or?
Yeah. So each DAG represents a workflow, and that workflow is made up of these map dependencies, these tasks.
Okay, so it contains the task within it. Okay.
Yep.
Got it.
And all the tasks make up the DAG.
Got
Could
it.
have been a little more clear on that. That's my bad.
Oh, no worries.
Yeah, I had a question here about start date, in that I've seen articles speaking to like not dynamically setting the start dates. And I was wondering if you could speak to like best practices around start date selection.
Yeah. So I think generally best practice is to use a static start date, not a dynamic start date. And that's because when you go to run a date for, when you go to run a task for different dates, or so you go to run a DAG for different dates, and you want to go back and change a particular date, you want that start date to be locked in statically. So if you make any modifications to it, it doesn't change anything else other than that particular run that you're trying to change. That's a bit of a contrived example. I think from my experience, you don't notice that your dynamic start date is an issue until you have to go back in time and rerun workflows for a specific interval. And when you do that, the way Airflow handles a start date just doesn't play too well with taking a workflow that's already run and rerunning it for some amount of time.
Got it. Thank you.
So kind of moving on to the next piece, I want to talk about Airflow hooks and operators a little bit. We talked about hooks being the interface to use a system. Operators are what actually comprises of your tasks, and they're what hold the logic behind your workflow. Here, I'm using a Python operator, and this Python operator takes a Python function as a callable, and it executes this Python function. But a lot of times in data workflows, you're going to be repeating steps a lot, and it makes sense to abstract out some logic into other operators. So I'm going to go into another DAG that I have here. That's called S3 upload copy. Look at the graph view. It's the same DAG I had as before, but now after uploading the file to S3, it copies it into a different bucket. And let's look at the code behind this. So this first part is still the same, where I am creating a Python function, creating my DAG, and running through this list here to create 10 instances of those tasks. But then after that, instead of running another Python operator, I use one of Airflow's built-in operators called the S3 copy object operator. And using this operator, I can just fill out the parameters needed for my workflow. And I can make it so that my DAG file almost looks like a config file, where all I'm doing is calling this Python object, filling in a few parameters, and it executes the logic for me. Notice in here, I'm not telling how that file should be deleted or where exactly what the logic of that operator should be. I'm just giving it a set of inputs. And with this set of inputs, it encapsulates the logic for my workflow. One of the best parts about Airflow is that it has a ton of built-in operators that you can just import like any other Python class. So I'm going to go into the core Airflow repo here, Apache Airflow, and then go into Airflow, contrib, operators. You can see that there's a bunch here for a lot of really, really common use cases in data workflows. So I can go Mongo to S3, MySQL to GCS, a whole slew of them that really make it so that you can get a lot done really quickly with Airflow, because all of these classes and objects are already written for you, and you just have to fill them in with the parameters of your workflow. So taking this example and extending it out a little bit more, suppose I wanted to delete those files after they were copied. So I'll go into S3 upload delete. And here I added a third set of tasks, this delete file. And if I go into the code view for that, you can see that I imported this S3 delete object operator. And in the same way as before, I just added that operator to my task and put it downstream of my dependencies. So now this workflow will go from start, generate the files, copy them into another bucket, and then delete them from the first bucket. Something that scaffolds what a regular data workflow could look like. Another reason I want to, go ahead.
I had a question around operators, in that I read like a fairly popular like Medium post speaking to like the case to be made for like using like a Kubernetes operator, and sort of, if I could get some understanding there, the best I was able to get out of the article was it kind of separates out. It makes a case that there's a mixing of like orchestration with execution, through like using multiple custom operators. And I'm curious to get your take on that.
Yeah. So I think there's a few blog posts out there that like the ones like we're all using Airflow wrong and just use the Kubernetes Pod Operator. I think GitLab has a blog post on that as well. I don't think there's anything fundamentally wrong in that approach. You know, if you want to run all of your jobs as, let me take a step back. A lot of Airflow best practice is to kind of offload as much compute into other things as you can. So you can use things like the ECS operator, where all it'll do is it'll call ECS jobs, and you just kind of give it the image you want to run, and the compute is offloaded. You can also do things like a Docker operator, the Kubernetes Pod Operator, where it'll run a Docker image or a Kubernetes pod, which will let you manage your job separately from the rest of your Airflow stuff. You know, so if you're managing your data science job as a Docker image, you can just push to that Docker image, and then the next time that job is supposed to run, it'll pull down the latest version of that job and just run the latest version of your data science job. I don't think there's anything wrong with that approach. I think it's just more like what fits your team the best. You know, if your team is really good at Docker and really savvy at using Docker images and containers, and that's how your data science team prefers to do things, that approach works perfectly fine. You know, maybe if you want to use some more of these built-in operators because they let you move a little faster, That's perfectly fine as well. Shamelessly talking about Astronomer a little bit. One of the big benefits of using the Kubernetes Pod Operator is that you can actually set a resource request in each of your tasks. So if you know a certain task is going to take more resources than another one, you can say like, hey, give this one task 10 CPUs instead of whatever my default is, because I know it needs a lot of horsepower. You can also do that same thing in terms of giving tasks special resources with something called the Kubernetes executor. That's a feature that Astronomer supports as well. And you can just kind of write something like this that says, give me a request memory, a limit memory, a request CPU, and a limit CPU. And I can just pass this config directly into one of my tasks. Executor config equals that. And now when this job launches, it'll be launched with that many resources when you run it on a kube cluster. So I don't think any approach is really wrong. It's more about what works the best for you.
Awesome, thank you.
Cool. And I made this workflow fail intentionally, just to kind of show you the dependency-driven aspect of Airflow. So the first step went fine, where it generated these files and uploaded them to S3. But for whatever reason, the copying the files over didn't work. It could be permissions, it could be maybe my S3 credentials stopped working. So these tasks were marked as failure. And then because these tasks failed, these downstream tasks never ran. So these are marked as upstream failure because their parents never finished letting this task run. This is really powerful when you're kind of doing a lot of things in your workflows and you just know where exactly something went wrong, so you can go ahead and fix it. Especially if you have business users that are kind of dependent on the data you're getting them, or if you're an analyst and something really doesn't look like in the data that you're using, you can actually see if there's any point in your workflow graphically where something did or didn't look right. More than that, you can actually see you can see a lot of metadata in the Airflow UI around your tasks. So you can see how long each one took. This is a really bad view. Let me show you a better one. This upload copy. I go to Gantt view here. So I can see how long each of my tasks took, the delay between tasks, and so on and so forth. And that really kind of gives you an extra bit of visibility into your data itself, because you just have some more metrics to go by and so on. And there's a few other tasks here as well. You can see a history of every time your DAG ran with this tree view. Let me look at this one. So I can see this DAG ran 4 times, and it only finished about 2 of those 4 times. I can view the duration of different tasks, and some details about the DAG itself as well. So the Airflow UI, definitely needs a bit of a redesign, but it is really powerful in terms of the amount of information it can give you about your workflow. So lastly, and this is something that's more of a coming soon that we're looking to kind of collaborate with the community on, is we're really looking to make Airflow more friendly to machine learning use cases. So this sample DAG that was written by one of my colleagues, Daniel Iberman, shows using something called a paper mill operator, which lets you run Jupyter notebooks and kind of sets it up such that you can do hyperparameter tuning with just a couple of lines of code. Let's look at the code for this guy. This one's a little more complex, but I'm giving it a set of estimators and a loss rate. And now I'm going to be looping through these estimators and creating tasks dynamically. And based on how this workflow ultimately runs, I can go in and see the details for each particular task. And that gives me a way to do hyperparameter tuning in Airflow. This is kind of the new way people are using Airflow for machine learning. And something that us as Astronomer, we're kind of looking to work with data scientists and other end users around how we can make Airflow a more machine learning friendly tool. Awesome. So I think we're just about at time here in terms of the time for the talk. So that's everything I had for this. Thanks everyone so much for listening, and happy to take any questions as well. And my screen won't stop sharing.
I have a question, Viraj. So it sounds like connections and using hooks was one of them, but are there any like other pro tips that you have for someone who's just getting started, thinking about like making sure that the way you're implementing this is really scalable and things like that?
Yeah. I think another one that was mentioned is keeping the start date static. That's one of the ones that you won't notice hurts you until it ends up hurting you. So that's definitely a huge one. Let me see here. Let's see if I can show you some other in the context of something else. Another really good thing to try and enforce with your workflows is this concept of item potency. This one of the ones that's like a lot easier said than done. You know, you want to make it so that when your workflows run, it doesn't matter how many times that workflow runs, it still doesn't change the end state of your data. So, you know, the classical example of item potency is upserting versus inserting. You know, when you upsert, it doesn't matter if you run that command 10 times or 1 time, the end result of the database is still the same. And I think the last one is just like Airflow can be kind of hard to run. So if possible for your organization, you know, use a managed service if you can, be it Astronomer or Cloud Composer, just so you can spend as much time focusing on your data as you can, because the Airflow DevOps burden is, you know, we wouldn't be a company unless Airflow was really easy to run, or if Airflow was really easy to run as a user.
We're actually already signed up.
Oh, perfect.
Good tip.
Oh, my screen won't stop sharing here.
It's a lot prettier than the standard Airflow, the UI that you guys have.
That's great to hear.
Raj, I think we're just stuck looking at your screen forever.
Yeah, right. I'm going to, why won't this button? Right, well, how can I leave a Zoom call if I'm not on, my screen is being shared? Show details. Oh, there we go. Awesome.
I just stopped your screen from sharing.
I was about to chime in and be like, Caitlin, I think you can.
So Palladium, maybe you could tell us a little bit about your experience, what you're using Airflow for, kind of how it's worked out, what implementation was like for your team.
Yeah, for sure.
Quick overview, that might be helpful.
So yeah, for sure. So hi, everybody, I'm Flavian. I'm data engineer. I've been using Airflow and Astronomer in this case at my current company, Updater. And actually, to some extent, it's really interesting to think about what it was like when Airflow didn't exist. So we're using Airflow for, you know, the very basic needs of doing ETL, which in this case means, you know, you need to capture data from various systems, whether that's your production database, your third-party vendor, some log system that you need to capture. And we're trying to put all this data in one place, which is kind of our data lake. In this case, we're using Snowflake. We're all pretty familiar with Snowflake. You know, some of you might be using BigQuery, but the main idea is then, you know, there's a lot of jobs that happen to load the data into Snowflake, and then there's a lot of jobs that happen within Snowflake, whether they're, you know, DBT models, or whether they're simple queries, or whether more advanced, you know, Python operators and you know, combination of operators. The key takeaway here is, again, we're using Airflow to schedule all those events, schedule all those tasks, make sure that the dependencies are handled, and then we're offloading as much as possible. Related to that previous question, we're offloading the compute as much as possible outside systems. So in the case of Snowflake, that's really straightforward. It's like, hey, you have this SQL query, run the SQL query. In some of the cases, it might be a little bit trickier, right? If you have a very complex Python job and you don't necessarily want it to run on those local workers, how do you extract that away? And so this is where some of the comments around the Kubernetes Pod Operator can come in. But yeah, for the most part, we're trying to keep it simple. So we have about 50 models. And so if you're new to Airflow, definitely recommend picking something very simple. Try to find something that has an existing operator where you don't need to worry too much about the chain of operations, and it's really just something that can execute a task for you. It could really just be a case, and we have some jobs that do that. It could really just be a case of, hey, Airflow, run the SQL query once a day. And that's all it's going to do, and that's totally fine. And then you build up from there, right? You build up kind of a chain of SQL operators. You start thinking about, okay, well, what if I also want to send an email once that SQL executes? What if I want to build a model at the end of this and start making decisions more programmatically? So that's the sort of thing that you get more familiar as you ramp up. But that's kind of what we're using it for, yeah.
I think you brought up something really, really interesting, Claudian, that like a lot of times the DAG, once it's kind of like, it changes with your business case, as you need more queries or maybe more steps or additional reports, that DAG is almost a representation of how data moves through your organization.
Yeah, exactly. And so oftentimes, oftentimes as data analysts or data engineers, the main interaction that we have with stakeholders can be dashboards, right? But I think trying to move some of the process to be more driven around, either a Slack bot or some email automation, I think that can bring a lot of value as well.
Yeah, absolutely. So I inherited a borderline unmanageable cron situation. I'm super interested in migrating, but do you have any tips for taking something that already exists? Like if I were starting from scratch, I absolutely have like low-hanging fruit. You can come up with very simple things and build from there, but detangling everything that's been built in cron and figuring out what should be dependent, but is currently now just like, yeah, there's 15 minutes between those two because we think that's how long it takes for the first one to finish. Feels safe. Any tips on kind of what that transition might look like?
I mean, maybe my advice here would be, don't change anything. Like actually you can keep the same logic around like, hey, keep those 15 minutes apart between your jobs and just move them slowly to Airflow one at a time. Whether they're Bash or Python script, you can just have those be executed in a fairly simple manner. So it really might just be a case of pointing the operator to the files you already have. Applying sensors and dependencies can be overwhelming. So maybe that's something you figure out later on once you realize that, okay, all those jobs, they run once a day or they run once an hour. But you all know you want to create that dependency that B should not run until A is finished. But I think that's a lot of people don't necessarily worry about this too much. You can always have that weight, but to your point, as long as the job is that important, meaning that it behaves fine even if it's missing some data, or it doesn't fail silently kind of scenario, I think you should be fine.
Yeah, I would definitely second that in the terms of like, that's a great use case for the Python operator. You get to move everything and just, it gets working in Airflow. And then, as capacity allows or as need allows, you can kind of take it from there after, because you don't lose any functionality by just taking what you have, putting it in a Python operator and just orchestrating that with Airflow. At least then you get a graphical representation of what your data is doing.
And again, the whole story around like, creating an Airflow cluster can be overwhelming. So again, this is the pitch for Astronomer or Cloud Composer. And this is where you're going to see that potentially some of your workers might be too weak. You might have a case where your Bash operator actually does a lot of computing, and so you can easily tweak those values in some of those offerings. Again, because that can be overwhelming to do if you're not familiar with DevOps as a whole.
I was going to just chime in. I think this is my first time to chat as well. So I'm Andrew. I work with Claire at Fish Analytics. I used to work at a previous company that used Airflow heavily. The other good thing, just to like second what Flavian and Raj has mentioned, like if you dump everything as like Python operators, orchestrating it becomes really easy because Airflow is super modular. So you're going to write the operators that will look the same regardless of like which file you put it in. And if it's like squashing two separate tasks that used to have like a 15-minute delay, where like you start everything on the 0th minute and then you start this on the 15th minute for like an hourly job, to turn that into a DAG becomes like really easy because you just copy paste the entire, like you throw away all the boilerplate Airflow above it take the operator and like throw it in. So we particularly like that about Airflow. It's you can start as like separate tasks and then like squash them later and not have to do too much rewrites. Just making sure your dependencies are clear is a trickier bit.
Yeah, one thing that can catch people as well as you have a DAG that has many tasks that are very local and exchanging local data is to not actually rely on local disk. What I mean by that is because it's a distributed system, so oftentimes the local disk might be on one task, but it might be on a completely different machine on the next task. So as you're dealing with the dependencies, you generally want to use some sort of neutral ground, which is usually S3 or GCS for cold storage, which is where you're going to put your files to be caught up by the next task. Otherwise, you're gonna be like, wait, this file doesn't exist. And like, well, no, I just created it. And so it can be funky in that sense.
Yeah, I want to second that as well. I should have said that in terms of best practice is definitely don't rely on persistent storage between jobs. Use external storage wherever possible. Also helps with item potency because you'll be able to see exactly like you almost have an artifact for each step of your job as your workflow progresses.
Awesome, that's super useful.
Could somebody on the call talk about using DBT and Airflow together? It's like my understanding that you need something to schedule DBT, and Airflow is a pretty common choice.
I'm also very happy to talk about this because thanks to John and the team, we are, as of maybe a month ago, we are using DBT within Airflow. And there's many ways of doing it. My understanding is you have two choices. There is an existing operator which you can use, but really the most naive way is to use the bash operator. And what the bash operator is going to do is actually going to mimic what you do on your local machine, which is actually just running the DBT command line. So it might just be, DBT run, and then you specify your model, and then that gets executed within a worker. And so very similar to what you're doing locally. So don't worry too much about changing your workload. It's really just taking that one command that you're running, whether you're running one model at a time or whether you're running, your whole suite of tests and models in one batch. You can do that using the bash operator.
So then you can set up like a DAG with all the different pieces, or is the DAG within DBT? Like,
that's an open question. Basically, that's a question that you can have to decide. Both DBT and Airflow can handle dependencies between tasks. In the DBT concept, that's called a model. And you're gonna have to choose, right? They can both handle dependencies, so you can either have Airflow run all your models and DBT handle the dependencies, or you can have Airflow handle the dependencies, and then each task is a really small piece.
Any recommendations from anybody?
I'll chime in. I'm Claire, I'm the DBT community manager, so I have a stake in this conversation. From what it sounds like Flavian's doing, the recommended way that we'd say that someone should use Airflow and DBT together, which is to use the bash operator. DBT DAGs often have hundreds of nodes, and the way that you define dependencies in DBT is you just like select from a preceding model. There's none of the like double arrow syntax. So the dependencies are kind of more like inferred rather than explicitly defined. I mean, they're in code, but then they're not like this. Okay, this depends on that. It just happens as you write. And I think we have seen some people in the past write scripts that parse a DBT DAG because it's a pickle file. It's a file that a lot of systems can read, and try and turn it into an Airflow DAG. And I think what you end up there is with this Airflow DAG that has hundreds of nodes is like you get like kind of worse visibility into what's happening. From what I understand of Airflow, like doing dynamic DAG generation is sort of doesn't necessarily fall into best practices. So we tend to say like, let the tools do what they're really good at. DBT is really good at managing DAGs of SQL transformations. Airflow is really good at managing DAGs of like entire data pipelines. And so invoking DBT through the bash operator is the best way to get those two tools to play nicely together.
Just to add to what Claire said, what that does look like in practice is like if you have seed files in DBT that usually have to come before you build your model, you'd have like one of your tasks in your DAG would be like DBT seed, and that will upload all of your CSV files. And then your next task would be dbt run. And so the dependencies of your dbt run will remain in that dbt run command, and that's just one command on Airflow. And the good thing is, like, if it fails in Airflow, Airflow also gives you a snippet of the logs and will show you like which model in dbt failed. And so you'll still get the best of both worlds, I would say, where like Airflow shows you that it broke on this step. And then when you look at the logs of Airflow, it will show you what dbt says broke, if that makes sense.
Hi, I have a quick question. I'm Peyton. So I'm curious more of like the back end of this. So I saw that you're using localhost as the like whatever where you're hosting Airflow. Are all your Airflow instances located locally, or is there a possibility to have it hosted in AWS or GCP? Yeah, because I could see the benefit of having it locally for like development environments and stuff like that. But was just curious if this was more just for the demo or if there's different possibilities.
Yeah. So I showed the demo one just to show you the first part of that developer's environment, just getting something working on your machine. Most people do host Airflow inside of their cloud, be it AWS or GCP or something. As far as Astronomer, we have a SaaS service that we host in our GCP cluster. And then we also have an enterprise product where you can just deploy the thing inside of your own cloud as well for whatever data security or data privacy reasons. So what I was showing was mostly just a local development flow. And then most people, they either have CI/CD set up or something that takes their DAGs from running on localhost and pushing it through running into the cloud somewhere or wherever your compute runs.
Okay.
Yeah, we at Updater we have a very similar setup where we have local development, which can be useful but is very limited, and then we have a staging environment which tries to replicate production settings as much as possible. And then we have the actual production, which nobody can push to. We are using CI/CD, like you mentioned, which again can be a very easy integration if you're using. In our case, we're using Circle, so there's some existing resources around that.
Awesome, thanks.
What's the reasoning that people are using Airflow to schedule dbt tasks? It's because of dependencies with other non-like SQL transformation tasks?
I think that's, you should have to go ahead, Flavian. You'd have a better answer than I would.
I mean, I guess it's more for clarification is what's the alternative?
No, the alternative using, like we use dbt cloud and we're super happy with it.
Right. So I think it's less about, so dbt cloud and Airflow can both run dbt jobs. The main reason why people use Airflow is for everything else, right? So if you're thinking about, hey, I have a dbt job, but also want to, say send an email or also save the data into another place. This is where you're going to reach some of those limits where you want to go beyond dbt. Some of those examples, like just running a simple Python operator can be really powerful. But yeah, if dbt cloud works for you and it's covering all your needs, then that's great. I think they're competing product without necessarily being competing with one another.
We have a lot of customers that use dbt cloud and Astronomer cloud in a very complementary fashion. So I think like as far as we know, they're very complementary. And I think a lot of times also for some of our customers that have heavy compute that runs, like they have one point in the workflow where they need to spin up a bunch of nodes on a external Spark cluster or something, or Databricks or whatever, because that's what the demands of that are. They'll kind of do a lot of things with Airflow and dbt in tandem to do like data quality checks before that like quote unquote expensive workflow runs, to make sure that like, hey, my revenue isn't -7 or something, and really
Yeah,
kind of
that makes sense.
pushing that logic in.
Cool.
Are there any other really cool things that you've seen people do? Or any other sort of like way beyond the bare minimum inspirational tasks for using Airflow?
Yeah. You know, it's one of those things that when you can do things dynamically with code, you can just imagination runs wild. We had a use case previously where we had a UI that people fed information into, and then on the back end that would create DAGs and start loading data somewhere. So we kind of had this like a user-facing product that made it so that you could use input information, and then that gets translated to DAGs on the back end. And all those DAGs were kind of completely removed from the end user. So that's one that I think is always really cool when you can use Airflow under the hood without exposing it to users. And I think as far as the Airflow roadmap goes, you know, I think there's going to be some more work done to kind of support those types of use cases. It's kind of a weird fit right now, but it's possible. I think the coolest use cases to me are just when some of our customers do like computer imaging or something that's really compute heavy, and they have to make sure all of these little conditions are met before they can run that one job that's like 10,000 node cluster that has to spin up for 3 hours, you know, and then like that compute really costs them money that have to be very, very careful around when they call. So those are some of my use cases, my favorite use cases personally, just knowing that like it lets people rely on their data a lot more and kind of encourages them to make sure that their data is correct.
Yeah, absolutely.
At my last company, we did something kind of funky and kind of hacky. So we were trying to get everyone off of cron so that we don't like have things hidden that are like touching data and messing with other people's stuff. But we also couldn't get everyone to commit to building like full-on Airflow jobs because like we also like had a really high SLA and like maintenance requirements. So everything had to be Dockerized, and like half the people didn't want to like touch Docker. So instead, we like our entire development environments were all in the cloud. So we ran like Jupyter Hub, and you can spin up like whatever IDE you wanted to run, whether it was like Jupyter Notebooks or VS Code or RStudio, you can like just pull it up on any browser. And everyone's dev environment had like an Airflow folder. So if you dropped an Airflow file, an Airflow Python file in it, there would be like this dev Airflow cluster that would just pick it up from everyone's individual folders and run it. So it's like essentially like a cron, like unified cron scheduler. And so the central data team had like complete oversight on what people were building ad hoc. But you could like run the flexibility of potentially breaking that entire cluster, and it's fine because it's all dev runs, was what we told them. And then if they're ready to like mature it, they can like pair with the central data team, and we can Dockerize it for them and like graduate it into a more production workflow. That's kind of what we did. It was a bit crazy, it was a bit hacky, but like it got us at least one step further of like people doing a bajillion cron jobs separately in their own computers.
Yeah, that kind of like idea of a single pane of glass for all of your workflows. I think like that's always really cool when a customer gets to kind of get to that point, because like you said, you know, nothing's running on someone's laptop anymore.
Any other questions? All right, awesome. Well, thank you so much, Raj and Flavian, especially Pete, and it looks like Ian dropped off, but thanks for joining as well. This has been really awesome. I really appreciate the time, and I love that these talks have kind of like dovetailed with my own actual interest in changing our stack, so it's always selfishly very helpful. But I'm glad it seems like others found it helpful as well.
Yeah, thank you so much.
Thanks, everyone.
Thank you all for listening.
And I should also mention that since we all met through Slack, there's a great Airflow community. So there's another Slack channel, and you're gonna find all the open source committers. And if you have any issues, feel free to jump in there, and we can help you.
Awesome.
Awesome. Well, thank you, everyone. Have a great afternoon, evening, morning, whatever time it is where you are.
Thanks, everyone.